Welcome everybody out there here to our next webinar at JFD Bank, and a warm welcome in the name of JFD Bank as well. My name, Stefan Friedrichowski, as always, for, let's say, those kind of webinars. Today, we have the 17th of October 2019, and it's really a pleasure for me to have you all here to the webinar about human meets artificial intelligence, who is a better trader. Okay, that kind of title has already two aspects. One is in general talking about artificial intelligence, and then transfer that to trading, and finally to the question, who's the better trader? The machine, the computer, or the trader, the human trader? Let's see. In general, today's talk is more an introduction to artificial intelligence at all. So more in general, because I think on the one hand, artificial intelligence is just a buzzword during the last couple of months or even years. And I think it's a good idea to know a little bit more about that, at least how artificial intelligence works, how it is trained and taught, and finally we will do the transform to trading as well. But honestly, that's just a minor part. But on the other hand, trading and artificial intelligence is quite a good combination, because things which might be not that obvious in general in artificial intelligence become much more obvious when we talk about trading. Later we will have something like a cost function or a profit function that is normally meant in general. For trading, the translation is quite obvious. If I talk about profit function, I think anybody would know what I'm talking about. Even that can be a little bit more complicated, but anyhow, so profit function, just as one keyword, is really obvious when it comes to trading. You might realize that you can already download the slides of today's talk here via your GoToWebinar control panel. And further, if you have any questions or just want to get in touch with me, drop me a line at s.friedrichowski@jfdbank.com, as seen here on my first slide. You know, whenever I have a webinar, I always have to show at least once the so-called risk disclaimer, because we talk about trading, we talk about investment, we talk about trading strategies, but finally, when it comes to your decisions, of course, you do everything on your own responsibility. Okay, I think that's quite self-explaining, but it has to be at least mentioned once during any webinar. Let me guide you a little bit through the topics of today's talk. And honestly, I have had the same talk, and not identical, but more or less the same talk, just 2 weeks ago on an international conference at the so-called IFTA, which stands for International Federation of Trading and Trading Analysis, something like that. Oh, sorry, I missed maybe the right translation of the shortcut. But that is an international federation. All technical analysts are joined together in that organization, and they have once a year one central meeting, and this time that has been in Egypt, better to say in Cairo, and I did the same talk there. But in this case, there have been about 200 participants joining that kind of talk. So for me, it's more or less a replication of that, and I even don't have to translate the slides as normally, because normally I do the webinar first in German one day before, and then translate the slides. In this case, it was vice versa, because the original slides, of course, have been in English. But back to the topic. So, talking about artificial intelligence, I need to show a short overview, and I will introduce you into that, of course. And then we have to compare the general aspects of human behavior and let's call it machine behavior, so that we have at least a first hint who might be better finally when it comes to trading. You know, if you join my webinars, that I have a more or less completely different point of view when it comes to trading. It's more a mathematical point of view. So I'm not that much related to charts. No, for me, I have time series data that is the input or any other data. So everything is data driven. And that's quite good, because when we talk about artificial intelligence, that's exactly the starting point for any neural network. We will introduce that, of course, as well. And so we need a different perspective when it comes to trading. And I mentioned already the final buzzword around artificial intelligence are so-called neural networks. So that's an adaptation of the human brain, and I will introduce those neural networks and how they work and how they learn, because that's even the more important part, because we want to teach them. We want really to get to the point that we do not put that much information ad hoc into the system, into the machine. So we don't want to have already an idea of a trading strategy. No, here the point is that we will want to teach the network, and the best would be if the network is teaching itself. So if it doesn't need any human impact or influence or a hint, and that's what's really possible with neural networks, that they really learn by themselves. Finally, I will show and share with you some results of my own neural network trading activities. Still, it's not a live account, what I normally do when I talk about trading. It's always good to show really live trading results. In this case, it's not a live trading account, but at least that you get a glimpse of what's possible. And still, it's not the holy grail, of course not, but let me go into that topic later. Okay, this slide has been for Cairo, just to talk a little bit about JFD, what we don't have to do here, because I assume you know everything around and about JFD, what you can trade, that you can trade stocks even commission-free, and cryptos can be traded as well, those commission-free as well, the CFDs on cryptos. But anyhow, we don't need that. Let me give you a short overview about artificial intelligence at all, because that is something which did not start during the last couple of years. Okay, it has been in the news, but people are in that topic already more than 70 years, starting about 1950. So those numbers, honestly, I took those from the literature. I have not really tried to confirm them, but anyhow, that's what I found there. So starting already in 1950, artificial intelligence, okay, but now the question is how to define it. I mean, how to define artificial intelligence, or let's start with how to define intelligence at all. That's really a tricky part, because it's not really quite easy to give a clear definition of intelligence. You might have something in your mind, that's good, but something like a measurement, the measurement of any distance or time difference or whatever, that's much more easy than to measure intelligence. Okay, there are contests about that, and then you get a number of 100 whatever, but that's really a complicated stuff. But the definition of artificial intelligence is quite easy. Any technique which enables a computer to mimic human behavior. Okay, maybe you would have not thought that it's that easy. So do I. But it means that any tools which help human by mimic human behavior are already called artificial intelligence. So that means even a machine which is transporting something from A to B could be something which is called artificial intelligence. Okay, you would not maybe join the same opinion, so do I, but anyhow, something which mimic human behavior is already to some extent artificial intelligence. Okay, talking about IQ, it would mean maybe a 5 or a 10. The average human, I think, has a 100 level. But anyhow, so it's really low level stuff, but it's already helping this human. So that's good. So let's take that as a starting point. Since 1980, we talk already about machine learning. And that is a subset which uses statistical methods to enable machines to improve with experience. Hey, that's quite a cool clue. There are two very important aspects in that sentence. The one is to improve with experience. And that's really good because that's a little bit already the adaptation of the human mankind, or the human development. Think about you as a child. So you got more and more experience. Things have been explained to you, maybe by your parents or whatever. They have they put their fingers on a tree and say, "Hey, this is a tree, this is a cat," and so on. So you get information and you improve by experience. Maybe first you can't distinguish between a table and a chair, but with more experience, you can distinguish between those two furnitures. That's the one thing. Improve with experience as a key element of machine learning. The other thing is, and that's quite good because we are trader and those who look more from a mathematical point of view, statistical methods we use in order to derive trading strategies. Statistical methods, that means we don't think in black and white, we think more in probabilities. Okay, if we get a new picture with some unclear information, we would finally may say, okay, there might be a cat on that picture. So we use statistical methods. And that's exactly the same what we do when it comes to trading. That we don't think about the next trade is definitely with 100% a winner trade. It will never be. But we think in probabilities. And those statistical methods can help to learn. And think about your childhood. You have done the same. You did mistakes. And okay, your parents told you that is wrong and that is right. And therefore you train your own statistics and your own experience. So that is a key element of machine learning already starting in 1980. Since only almost 10 years, we talk about deep learning. And now it comes directly to neural networks. They have not been invented just 10 years ago. They are much older. But from that point in time, it's really possible to make computation of multi-layer neural networks and to really train a neural network with data, because we later will see we may have thousands or even millions of nodes and weights and neurons. So we adapt the human brain and try to teach that neural network in a similar way than we have been taught or still are taught by our own, by reading, by getting feedback, and that is called deep learning. And we will introduce that as well. Okay, let me start first with some success stories about artificial intelligence at all, because that makes a little bit more clear what we are really talking about here. So one example are that's almost the oldest application of artificial intelligence, AI, are email spam filters. That's good because your email provider knows any email before you get it. So your email provider can already get additional information. How often is the same email sent around? That might be already a hint that it might be spam, or it contains special keywords, and that is a self-learning process, but in most cases educated, supervised. So there are still humans involved, give some hints, and more those artificial intelligence neural networks learn even by their own. It's a little bit more obvious when it comes to artificial intelligence when we talk about games, computer games, for example, or any game you might play by your own as well. Starting already more than 20 years ago, there was already a chess computer called Deep Blue, and that computer won against the world champion Kasparov. That Deep Blue was more algorithmic driven and not already a deep learning algorithm, but it has already the capabilities to be better than the world champion. Wow. And that's now 22 years ago. Just 2 years ago, there was another breakthrough with the computer program AlphaGo from Google, and that played the game Go, which is even more complicated than chess because of the possible situations. And that computer program won against Qi Ji, who has been the world champion of the game Go. The other good thing about AlphaGo, that computer program or algorithm, that was a neural network, and that was taught by itself. How is that going? Let me explain to you a little bit. Think about you have two computers, and you just introduce or you code into the computer the rules of the game. And then you let the two computers play against each other. And now it comes to a profit function. You finally say, what is good? Good is winning. And after they played one game, they can analyze and realize what has been good, what has been wrong. So they can improve themselves, which is good, because that is another key aspect of any deep learning network. The other good thing is they can do that playing against each other extremely fast. So it took not very long that the algorithm was already better than that best Go player Qi Ji. The same algorithm was applied to chess once again. And there I can tell you a really an astonishing number. So we start just with the rules of the game of chess, code that into the computer, and then let the two machines play against each other. And after only 4 hours, that computer could not be, was already better than any human in 4 hours. You may know about chess, and you know that's a really complicated game. So that algorithm, that neural network, was able to learn it in 4 hours better than any human. Wow, that is a success story. And 2 years later, this year, the computer take over the game poker, which is once again even more complicated, and it's more complicated because of what is called incomplete information. You know, at poker you don't have any information available because people have their cards in their hand. That's completely different to chess or Go because there any information is available. But even that game is now taken over by computer. Wow. We have other sources about or success stories about artificial intelligence. You might like them or not, but the product placement by Amazon, Facebook, Google, and Co. Is completely guided by artificial intelligence. And I have to admit that they're really doing a good job, at least if I look to my personal advertisement after buying something. Yeah, the recommendations are not that bad. Or you hear about self-driving cars, that those might be even close to market introduction. And you see, I made some question marks behind that because there are some buts. I think about that, and I will tell you in a minute. In general, a little bit beside self-driving cars, all the other examples are highly specialized tasks. So that is something which is quite common for all those kind of applications. And it might even be one of our conclusions today that the computers and artificial intelligence is perfect, but maybe still now only for highly specialized tasks. That might be. General aspects maybe cannot be taken over that fast. Let's see. Let's compare first human and machine in general. And let's talk about the advantages and disadvantages. Of course, when it comes to the machine, speed, yeah, is outstanding, precision, outstanding. The machine is emotionless, which is really a good skill. Okay, one might not name it a skill for a machine, but in comparison to the human, it's definitely an advantage. And the machine is, at least in principle, 24/7 capable. If there's power, and maybe if there's internet, if you need at least the internet as one additional source. The human, yeah, we have to sleep. Okay, that's good advantages for the machine. Let's think about the human more in general. We have very good advantages. One I would call intuition. That is, let's call it a skill or a feature, yeah, which is more like an in English we say educated guess. And that's a very good phrase. So we just don't guess. No, we use all our information in our brain in order to judge the now new situation. That is something which is outstanding for a human. Or just as another aspect of a human, our creativity is once again outstanding. Think about art and maybe pictures of you have seen. If you understand them, they are really creative. And there are other examples like music, composers, whatever, you name it. Creativity is a big advantage of a human. We can create new things just from scratch, even in a few seconds. And it might even be really good. A disadvantage of the machine is, at least up to now, there's still human input necessary. If that is not anymore the case, and we are on the edge of that a computer is coding a computer, so it's developing its own code. That is more an evolutional step, and that is quite interesting aspect if we come to that stage, because then we can adapt the nature at all. You know that even the human is just a product of evolution, but the computer might do it much faster. We are not there, but maybe quite close. Disadvantages of human, of course, psychologically, mistakes we do, and we are quite small. Mistakes, think about trading. Even I have done trades totally wrong just by pressing the wrong numbers. I want to buy a 0.01 lot trade. It was US dollar, Japanese yen, and I bought one lot instead. And then I was a little bit surprised how money goes up and down. Oops, I closed the trade, fortunately in profit, but yeah, mistakes happen. In general, it looks like a clear advantage for the machine, but we have to talk about the buts as well. And let me mention already one. You have realized in my last slides that for self-driving cars, I made some question marks behind. The good thing is that around self-driving cars, there's an open source community as well, not only the car manufacturer, at least a few of them, they really release data for open source, and so that other people can try to investigate those data. And there has been one university, one team doing that, and they realized that if you change in some certain situations just a few pixels, and the number was 6, within the input, and those are camera pictures as one input of self-driving cars. If you just change 6 pixels, the car would have made an accident. And that makes some really big question marks behind self-driving cars. Noise in general is still something which is, let's call it poison to any artificial network. You can have even an artificial network you can talk to in order to make appointments or reservations for a restaurant. But if behind you put some noise, then the machine might not understand you, but not because like humans, because the noise is too loud. No, just because that there is that kind of noise that might disturb any neural network at all. There are more buts, but let's dive into trading and into the machines. But let's start trading really from a mathematical point of view. And for me personally, trading in a nutshell is just one equation. Okay, there's a formula, there's a function with some input parameters. And finally, the decision is long, short, flat. Let's keep it that simple. There might be different underlyings simultaneously or just one underlying as output. Let's think about euro, US dollar, long, short, flat. That's all. So there's a function with some input and there's an output, long, short, flat. The input might be, of course, the time. Of course, the price history. How long? I don't care. At least not within that formalism. There might be key figures. I don't really like it to name them key figures like indicators, because key figures in general are just calculation out of the price history. So it's not really a new information. There might be other inputs for that equation. News, fundamental data. We need to know about trading costs, spreads, commission, for example. Of course, we need some money management, like do I have already open positions, how much money I have left in my account, and those kind of informations. During the last 2 years, I tend to add at least Donald Trump's Twitter account as a news input feed as well, because even that might have an impact on any trading decision. So overall, we have a huge amount of data input, and then we do decisions, long, short, flat. That is trading in a nutshell. What it means that finally we have to make decisions in each millisecond. Okay, that's like you sit in front of your computer and you want to trade. The human does not tend to really do decisions in milliseconds, and of course we are not really capable to do that. We might use things like buy stop orders, limit orders, stop losses, take profit levels, and something like that. But that is just a conditional equation in the same kind I introduced here already. And the condition is just the price. If the price hits a certain level, okay, then that is the trigger. So it's not really something new. But what we try to do, we have a so-called profit function, something we want to achieve. Playing chess is to win the game. As a trader, okay, we want to generate profits. That's quite obvious. And when we look to trading, we can think about, let's say, 4 different trading approaches. And honestly, the list might not be complete, and the borderline between those might not be that sharp. So there's a smooth transition maybe from each to the next one. Let's start on the left upper side, just the chart. And what we do is we analyze the chart with technical analysis, market analysis, whatever. We draw some lines, we draw some indicators, some levels, Fibonacci levels, you name it. Out of that kind of analysis, that chart analysis, we derive our decisions about trading. Okay, that's one, the maybe oldest approach of trading. But there might be another one. Let's jump to the right. I call that rule-based. So we set up some certain rules, like we might have done some investigations, some statistical investigations, and we realized that on Friday it's a good day to trade gold long. We even might not ask why. We have just that statistical observation. And if that turns out to be good, why not? So we have an edge, we have a probability advantage, and that is a rule-based trading. You might have lots and other rules as well, but that is what I just call rule-based trading. Then we have another kind of trading approach, which is based on algorithms, some conditions which have to be reached. So it's a little bit more complex way of rule-based, but we train or we code finally an expert advisor, and that kind of algorithm is then translated into trades, and the machine is doing the complete job. And last but not least, we have those deep neural networks with lots of nodes and connections, links between those nodes. And that is a topic we will now go into, to have that as in general as artificial intelligence and for trading as well. Neural networks is just the adaptation of the human brain. And I'm not a biologist, but you may even know more about the real behavior of the brain than I do. But what we have is we have neurons, and those neurons are linked, connected to other neurons. And then we have signals like electrical signals connecting one neuron to the other. And that is in total our human brain. Our human brain has about 100 billions, and you see what I really mean, because it's always complicated to talk about millions and billions. So it's a 1 with 11 zeros. That's the number of neurons we have in our brain. And if you compare that to a computer, it's a little bit tricky to say, is a neuron like a CPU or like a data storage, 1 byte or better to say 1 bit. It's a little bit a combination of both. So therefore, the number, if it would be CPUs, it would be really outstanding. If it's just the memory, okay, lots of computer have same amount or even more. But it's really the combination that neurons are memory and CPUs as well. Everything is now connected, and of course we have an input world, so sensors like our skin, like eyes, our ears, whatever. And we have outputs, that is talking, doing actions, pressing the button and buy one lot euro, US dollar, driving cars, walking around, whatever. That is our output. And the other thing about the human brain in general is, okay, it's teachable. So it can learn. From 1 second to the next, it's never, ever, once again, identical to a state before. So it goes around as we speak, and we can learn. Hopefully you learn during this talk as well. That's a good thing about the human brain. And the general learning method is reward and punish. Okay, that's maybe a little bit brutal. But that's exactly how it works. And think about your childhood. You have done things right, things wrong, and maybe you got something when you did it right. And okay, punish doesn't mean really punish, but maybe your mother was not that good with you anymore. Something like that. But that is a general learning methodology of the human brain. The older we got, the more complex it will be, and we can even feedback ourselves with, so we have some additional methods as well. Just for a comparison, a bee has just 900,000 neurons, and still that brain can do things the human can't do. They can fly around, and they do it quite well. Even in a storm, they can do it. So 900,000 might be already something quite good. But now, how do we transfer that into computers, into neural networks, and how they work? Yeah, the first thing is we just do the same like the human brain. So we have what's called input layer. Then we have inputs. Think about inputs might be historical price data. And just the first one here might be the current price, the next one, the price 1 hour ago, third one 10 hours ago, whatever. And we can have more input layers. Or it could be a camera. Then this would be just an input pixel, just as an example. Then we have additional neurons, and you can see they are always connected. That one is connected to all input neurons, and so on and so forth. And we might have more so-called hidden layers. And finally, we have that output layer. And if you think about my trading equation, that might be long, short, flat, 1, 0, minus 1, just as an example. So that's how we set up our network with layers, and those layers we might have thousands of nodes within one layer, and we might even have 1,000 layers. So we might end up with millions of nodes, similar to the human brain. But that's exactly the way how the computer, how artificial neural networks are created and set up in a computer. Exactly that way. So now the part comes to a little bit more formula way. So we have inputs, or just the input for a given neuron. So this central one here on the right hand side. And we have signals. And those signals are just combined. And that combination is indeed, in almost any case, that simple like this equation. So it's a weighted sum of those inputs. So we have weights for each input, and then we sum them up. And then with that kind of combination, we go through what is called an activation function. And that might, in a simplest version, just a threshold. If we exceed a threshold, we fire into the right direction. I use the same words like when it comes to human brain. one really calls that that way that neurons fire. So they let a signal through under certain conditions. Think about that kind of threshold function. So, and that thing here, that kind of combination is done in any node. That means finally that the most important thing within a neural network are just the weights. Within those weights, that is a memory, that is a learning process. So the critical thing is to find the right weights within that complex neural network. So that is how a neural network works. So the input is then transformed from the left to the right via those kind of equations, which are really simple. And if you do it a little bit smart, then you can do those things quite fast. Now we want to train neural networks. So let's talk about learning methodologies. And in general, I just will mention here three different kinds: labeled data, unlabeled data, and reinforcement learning. Transition, once again, is not that sharp as it might look like. Let's start with labeled data. And the easiest part, think about you have 1,000 pictures, and those pictures are labeled in terms of what's seen on the picture. Like on the picture is a dog, on the picture is a cat, on the picture is a chair, whatever. So that means you have labeled data. That is called supervised learning because there's an additional input. When it comes to trading, that kind of labeling can be done by the computer itself. Because think about a chart. Within a chart, a historical chart, you can always start a virtual trade at the end of any candle with a certain stop loss and a certain take profit, and you will see, because you can go into the future from that point in time, and you will see whether the trade would have been profitable or not, stop loss or take profit. So we can even label our data by our own. That's good. That's the way I did it for my example later. We can even use unlabeled data, but that means finally we take the same pictures as my first line, but without the information what's seen on the picture. Such a neural network will learn to classify, to separate those pictures. Finally, it cannot name a picture dog, but it knows what a dog looks like. Only the naming, but that's the same with languages. So I call a dog here dog. In German, I would call it a Hund, and I have no idea in any other language. Anyhow, so that doesn't really matter. At least that if we know what's really on the picture. So those kind of unlabeled data can be used as well. And finally, we use the methodology of reinforcement. And that is exactly that: punish and reward, as already mentioned. If something turns out to be good, we know that. If something turns out to be bad, we know that as well. At least if we have something how we want to optimize. And that is the so-called profit function. For games, it's just winning. For trading, it's profit. For classification, it's hit rate to get the best hit rate, about recognizing pictures. So just as an example. What we tried during the learning process is always to improve according to our profit function. What does it mean? Or how is it done with a neural network? And I really used straight away the example of historical data of trading. So we take as input historical data, as I mentioned, maybe price, current price, first 1 hour ago, 10 hours ago, 100 hours ago, and so on and so forth. And The funny thing is we really start with random weights as our connection weights between our nodes, between our neurons. If you start with random number, okay, that sounds really crazy, but that's the starting situation. But now what we can do is we can take our historical price data and our complete history of maybe 10 years and push them through the network. So what we would get is finally we would get an equity curve, because we always get those decisions like long, short, flat. And that kind of process for neural networks is called forward propagation, because the flow is from the left to the right. And now the only question we have is, how can we change the weights in a way that we improve our equity curve? And that can be done statistically just by random numbers again. And that is called backward propagation if you do it really smart, because we can do that step with some algorithms, which one is called gradient descent, and there are some other algorithms so that we can do that quite fast. But the question here is how to change the weights so that the equity curves improves, and then reiterate, because we cannot get the optimum state already in one step, but we can iterate. And that is how neural networks learn, changing weights in a way that our profit function becomes better. That mentioned algorithm, gradient descent, is quite simple. Even within the picture, everything is German, but anyhow, we have a starting point that is here. And what we do is we just make a small step to the side, just in order to get the gradient, the slope. Because if we now know the slope, we know the direction we should go. And that is just the next step in our iteration. We know that if we go downwards, if we want to find a minimum, then we are doing a step into the right direction. And we simply would stop when the slope reaches the zero. That's all. And that step cannot only be done in one dimension. Now, even in higher dimensional spaces, you can do the same kind of procedure. If you look here to the graph, we start here, and then in order to find the minimum, what we do is we do one trial step in this direction, maybe in the X direction, and one in the Y direction, and then we know into what direction we should do the next step. It's a little bit like standing on a mountain somewhere and looking for the valley, or try to reach the valley. We even with blind eyes, we can do that kind of procedure by doing those trial steps to X and Y direction, and then going into that direction which has the biggest slope south, also down, and then we reach, and now I have to mention, we reach a local minimum. So that does not mean that we reach the global minimum, but if we use different starting points, we might find at least something which is close to the global minimum. One of those big achievements since 2010 have been algorithms which enable us to do that for all weights within our neural network, just in one calculation step. So we don't have to do it for all the different weights individual. No, we can do it in a single step. And that kind of backward propagation was really one key invention for deep learning, just in order to be quite fast. Remember, I mentioned that we might have even millions of nodes, which means millions of weights. And to do that kind of optimization really needs some tricky algorithms. One other important methodology for learning with neural networks is test data splitting. So we have data. Let's think about the complete blue circle here. And now we do something really quite easy stuff here. We split our data in training data, and the other one are called test data or out of sample data. That means we teach and learn with our neural network with those 80% data, and there are other numbers like 70 to 30 or 90 to 10. Anyhow, we use those data for teaching the neural network, and then finally we do a test on our remaining test data, the so-called out-of-sample data, and only if our neural network behaves there good as well, we would go further with that neural network. So that is something which is quite similar to what I, for trading strategies, normally do with my walk forward methodology. And you might have seen that in other webinars already, that we use some history going into the future, which have not been part of our optimization, and then going further, step by step. It's quite a similar process, but it's quite important because otherwise we might end up in overfitted neural networks, like the same for overfitted training algorithms. Yeah, there are some other methodologies, pruning and so on, but I don't go into that. Just that you see a little bit of practical examples of neural networks and training. So what I've done here, I've plotted the hit rate of the sign prediction for a next H4 candle. And I have done that kind of investigation for 29 different symbols here. And you might think, oops, that looks crazy. And especially in the history, because there's 2006, 2008, it really looks crazy, isn't it? But let me explain what is really shown here. So I just optimize or train the neural network in order to answer the following question. Is the next candle, the next H4 candle of, for example, Australian dollar, Canadian dollar, a long candle or a short candle? Does it go upwards or downwards? That has been all the question. And what I plotted here is the difference to the 50-50. So because just tossing a coin would give you just 50-50, or here it would be the zero line. And now what I did, originally I started with data from 2004, which is not shown here within the graph, because those have been my input for the neural network and for the training procedure. And then I applied it stepwise for a little bit in the future. And those results, the hit rate is exactly what's been plotted here. But the more and more I go to the right here, the more and more I have had more historical data to train my network. And what you can see is that my overall hit rate stabilizes, saturates. That means finally, for any of those underlyings, I got a hit rate which is better than 50-50. That's good. Is that already a trading algorithm? Yes, but is it directly profitable? The answer is no, because hit rate is not profit. You know, a hit rate of 50-50, even for a trade with stop loss and take profit equal size, doesn't mean that you earn money simply because you have the cost of trading, spread, and commission. So we need more. But that was just my starting point in order to get a feeling of what's really possible with neural networks. just by training them with historical data, and the profit function in this case was the hit rate itself. Going for real trades, I used labeled data with a fixed stop loss and a fixed take profit. And in this case, I just plotted here trades for euro, Japanese yen. The variation between the different lines is just how the network looks like, how many nodes, how many hidden layers, how many input nodes, and so on. But what I achieved was really some good trading results. Just always taking the history and apply what I have learned there for the next future, and then going further. So even with different kinds of neural networks, I found profitable results, including costs. And the data input has been the historical price itself, but labeled because in the history I know that for a given candle, how a trade with a fixed stop loss and a fixed take profit would end. And that is what I achieved. You may ask, hey, why don't you trade it already? Now it comes back to the buts. I mentioned the self-driving cars. So I'm still not that convinced to do it already completely automatically, but I'm close to that because I have some more results up to now. But that's how neural networks work, and they can be applied for trading as well. That brings me already to my summary. And I started with the question, who's a better trader? The machine, artificial intelligence, or the human? And honestly, it depends on who you ask. I personally believe computers are the better trader than the human, but not only because of artificial intelligence, just because of mathematical methods. So even statistical derived trading strategies are quite good, and they can be executed directly with a computer. You might call it artificial intelligence as well. I would not name them that way, but in that aspect, definitely, I think the computer is a better trader. But we have those situations which we don't know. And I know from literature and a little bit even from my own neural networks that if something new happens, then we don't know exactly how the network will react. The key advantage of the human is definitely intuition, creativity, and our unbeatable experience. So we can even solve situations we have never been in, and we can give right answers to those kind of problems as well. But let me mention already the next step in computational science. And the next step is what is called causal neural networks. So they are not just data driven, they use data as input, yes, but they are more logic driven. What do I mean with that? Think about the following statement. If I say Adam is taller than Bird, and Bird is taller than Christian, then the conclusion is that Adam is taller than Christian as well. That's something which is quite easy for us as a human, but it's definitely quite difficult for any neural network so far. But if those neural networks can derive causal relationships between things, data, input feeds, and so on, then they might become much more intelligent than they are now. In general, the breakthrough of artificial intelligence might take longer than we think today. But what I have in mind is real intelligence, not highly specialized tasks, which can be done better by the machine than any human. No, we want to have more general intelligence. So If I ask a chess computer, please add up the number 8 and 9, the chess computer will not answer, because it's not trained for that simple task. But I want to have an artificial intelligence network. I can do, for example, any question and get right answers. And that's much more complex than anything we have today. Or if you ask a chess computer, oh, please take up the board out of somewhere and build the chess game, the chess computer can't do it. If you play with a human, no problem. So there are other relationships which are important as well, and only with those I would really call it intelligence. But maybe we are not that far from that. Computer getting smarter and smarter, faster and faster, and algorithms as well. And the same is true for trading. Hopefully you learned a little bit during this webinar that you have trained your neural network in your brain and get some conclusions for your own as well. It was not already a complete list how to create a neural network so that you can start trading with that, but that is really a task which cannot be covered in an hour. But at least you should have an idea of how neural networks work and how they learn and how they can be taught. Hope you enjoyed the webinar. The recordings you will find tomorrow on the JFD YouTube channel, and I hope to see you again for the next webinar. And have a good time. Bye-bye.